Okay, so let's talk about what it means to be the volume of a sphere. I teach this specifically in a fashion to try and get you to remember several formulas instead of just adding one to your list. Okay, so what is the area of a sphere? So far, does anybody remember what the area of a sphere is? What is it? 4 pi r squared. That's the area, the surface area of this sphere. Correct? All right, so based on the volume of a pyramid, can you make a conjecture about the volume of a sphere? Okay, the reason I say pyramid is, well, first of all, what's the volume of anything? Base times height. What is the base area of this sphere? Why? It's a sphere, right? So its base is not the great circle, which most of you would think, right? The base is actually the whole thing around it. Now, that may seem really, really complicated, right? But think about it. If you were to take the sphere, the very center of the sphere, and open it up, wouldn't the base of it be that whole circle, right? Like if you were to take what's like those candy oranges, or those chocolate oranges that have the wrapper on the outside, if you were to open that whole wrapper and spread it out, that would be the area, the base area of the sphere, right? Okay, so that being said, this little figure right here is like taking this piece right here. This piece, this is the outside. Like, let's pretend like we have one of those chocolate oranges, and I'm going to cut from the outside into the very core of this sphere. That's this piece right here. You see this? Let me say it again. This is the outside of the sphere. If I were to take this and make a slice straight into the inside of the core, and when you get to the middle, it'll be a point, right? That's this point right here. See that? This is like a chunk being cut out of this sphere.
Okay, so we just can't see the other end.
Exactly. We're on the back of it looking at it. So if I were to take all of these little, they look like rectangles, and core it into the center and pull them all out, what's this shape right here? It's a triangular prism, right? Because it's got a base that's a square, but it looks like... Okay, that's what that looks like right there. Correct? This is the base of it, and it's a triangular prism. Correct? If you had a whole bunch of triangular prisms and you put them, if I cut little cores out of the whole sphere and then set them all on a table, wouldn't all of their bases be the area of that sphere? Can you see that in your head, kind of? You core all this whole thing out until there's nothing left, and then you put them all. You'd have a whole bunch of triangular pyramids on a table, and the base of it would be that wrapper. Correct? What is the volume of a triangular prism? 1/3 of the base times the height. What did I just say that base is? This whole base. What did I say about the wrapper? So what do we know about the wrapper? What's the height? Why? Because it's the height of all of those triangular prisms, right? If you were to core it, it goes to the center, which is the radius. That is where we get the formula. Is everybody following me? This is the base. This is the height, 1/3 of it. That's where we get the formula 4/3 pi r cubed. That is the volume of a sphere. You are more than welcome, like I know Devin likes her formulas, use this. This is the traditional formula for finding the volume of the sphere. I will continue to write it out this way. Why do you think I would do that? It's easier for me to remember because now I'm not learning a new formula. I'm just saying I already know that it's 1/3. I already know the formula for finding the area of a sphere, and I'm just putting the two together. So to me, it's one less chunk to have to remember. This is the formula. This is it broken up into pieces.
That's a formula for the
Volume of a sphere. Volume of the sphere is 4/3 pi r cubed. Okay, let's move on. So let's use that. Find the volume of a sphere to the nearest tenth. Volume equals base times height. Right? So this is 1/3 of 4 pi 15 squared times the height. The reason you guys are going to say it's crazy, why does she have to write it out twice? Because many of you, if you write it out like this, I guarantee you, if you write it out 4/3 pi r cubed, are going to forget the cube. Because you're so used to writing pi r squared, you will forget that cube. If I write it this way, am I going to forget it? Nope. Like I said, cubed on a calculator, you just do the little caret symbol and then put 3. Ready? So if I put that in a calculator, I get 14,137.2 centimeters cubed. Okay, so this one's saying find the volume of the sphere to the nearest tenth. So I know volume equals 1/3 times 4 pi r squared times r. So I need to find r, obviously. So it tells me my circumference is 25 centimeters. I know that circumference equals pi times diameter. So if my circumference is 25, don't I just have to divide 25 by pi? Divide by pi. Divide by pi. Take 25 and divide it by pi for me.
well, 7.95.
7.95 equals the diameter. If that's the diameter, what's the radius? Divide that by 4. What? 3.97. That's all we need. 1/3 times 4 pi 3.97. At this step right here, I just need to put cubed because I already see it. Right? Why write it out again? And another reason I write it like this is because when I put this in a calculator, I'm going to put 3.97, cube it, multiply it by 4 pi, and divide by 3. That will give you the most accurate answer. You never have to push clear on your calculator. You could have put 25, divided by pi, divide by 2, cube it, multiply it by 4 pi, divide by 3. That will give you absolutely the most accurate answer. Okay? Awesome. What do you have?
262.1.
Jeremy? 263 point what?
85.7.
So that would be 9.
Yeah.
That's probably, did you do it like I said? Take that, divide, then that is the most accurate answer right there. So that would be centimeters cubed. That's what I have too.
So let's do that one.
I would. I mean, you take 25. You divide it by pi. You don't clear anything. You don't write the numbers. You just take 25, divide it by pi, divide it by 2. That gives you your radius. Cube your radius. Multiply that cube by 4 pi, and then divide by 3. Okay? All right, find the volume of the hemisphere. Same thing, only what? Cut it in half.
So what if you buy
So it's half
1/3
times 1/3 times 4 pi r squared times r.
So the percentage is 2/3.
Exactly what it means. So just like Connor said, isn't 4 over 2 just 2? Just one less calculation to put in there, right? So I'm left with 1/3 of 2 pi 3 cubed. Correct? This is 3. Which is 27 divided by 3, which is 9, times 2 is 18. What's 18 pi? I have c cubed. This next one, there's no need to write it down. I'm just going to talk about it real quick. Everybody okay? Ready? It's not hard, right? Compare the volumes of the sphere and the cylinder with the same radius and height as the radius of the sphere. If the radius of the sphere is r, then the radius of the cylinder is r, and didn't it also say that it has the same height too? So this is also r. Determine which volume is greater. Think about that.
It's the same. Because the cylinder is the circle that's filling it up. Okay, so what the question is,
Which one has more volume?
No.
You can fit the circle in there.
I say, I'm going with
What's Jeremy say?
Follow where.
No, it is.
Are you smart, Jeremy? What? You're not smart enough. I'm over. Oh yeah. No faster than following.
What are you saying?
C. Is you A or B? Oh my C, stand up.
Okay, I'm going to do it. What's the area of a sphere, or the volume of a sphere? A third of 4 pi r squared times r. What's the volume of a cylinder? It's not a third. It's just base times height, which is pi r squared times R. If this is 4/3, right? This is saying 4/3 of this, correct?
Yes, ma'am.
This is saying 1 of this.
Well, that would be 1 1/3.
That would be 1 1/3.
So that is base, no matter what.
Do you see how I just did that?
Yes, ma'am.
This is bigger by how much?
A lot.
1/3.
A lot. Oh, well.
Good job, guys.